Hello, in this video, I am going to talk about power functions. So, what is power function? So, by the definition, power function is a function look like this form. We consider this is power function where our a is any real number. This is also called the coefficient of the variable. And then n will be a non-negative number. So for example, 4x to the square, this is one power function. 5x to the 7, this is another power function. Or negative, the coefficient can be positive or negative. X to the a is a power function, or even a negative fraction, also a power function. But 2x to the negative 2 is not a power function because this has to be non-negative. So this is not a power function. Now, let's talk about the basic behavior of a power function. Now, let's take a look at this one, such as y equals x squared. We know that this is going to be a parabola. So what about y equals to the s to the fourth? Oh, sorry, this is a negative. Let's talk about the positive. So compare the blue one is s to the fourth. And then the red one is x squared, or y equals x to the 8th. Look, they all look like parabola, it's just with different steepness. Like, let's put a coefficient in front of it. Still s to the 6th. Look, all of this is still a parabola, but just with a different angle, how much they open up or how much they steep. Or let's put a decimals. 6x to the 8th, still a parabola. So here you may find some pattern. So they all look like parabola if the power is an even function. So remember that. Let's mark this down. So that means the end behavior, which means what is the end behavior, which is the long run behavior. What does that mean? Means the end of the function. If y equals to a times s to the n, and the n is an even number, then the end behavior is similar to y equals x squared, which is the parabola. The end behavior means what happened at the end part, which is these two parts. Usually when we talked about that is as x goes to the left, far left, which means is the which means as x goes to negative infinity, that means goes to the left. What happened to y? Y goes up, which is the positive infinity. As x goes to the positive infinity, which means when x goes to the right, y also goes up in this case. So we all learn the transformation of a function. What if I put a negative? Well, if the coefficient is negative, then the function is going to be upside down, such as y equals to negative 4x to the 8th. So the 8th tells us that this is going to look like a parabola, and the negative tells me this is going to be an upside down parabola. So that means as s goes to the left, which is negative infinity, y will goes down, which is negative infinity. As x goes to positive infinity, that means goes to the right, y goes to also negative infinity. Anyway, all of these power function, if they have even power, it's going to be similar to y equals to x squared. Now, you can make a guess. If the power function a as n and the n is an odd number, what do you think that will look like? Then the end behavior is, this means end behavior, similar to y equals to s cubed. Now, let's check that with our decimal. Close it. Now, the first one, I change it to 3. Look, we know that x cubed is look like the snake or the S shape. Now, let's look at the second one. 7 or 14.7, even 14.7. Still, it's look like a shape because it's the similar shape as the s cubed, because this is the odd number. For the next one, let's do something crazy. It's 18.1. The purple one still look like the snake shape. So, and then even with the coefficient, if it's an odd number, it doesn't matter. If it's as long as the power is even, such as 5. Look, oh, this is up, sorry. Let's do the next one. 5. Look at the green line. Let me close all of the other one. Just compare this one to the s cubed. It doesn't matter what the coefficient is. The shape, it will be similar to x to the cube, which is the cubic function. And then with the coefficient, it will only tell you that how they expand or stretch or compress. But if it's a negative, if I put a negative such as y equals to negative x to the 5th, it will be upside down. That's it. Now let me close it. All you can see is just negative x to the cube. It's just a flip. Okay, so let's mark this. So that means the end behavior means where the arrow goes. If a is a positive number, the coefficient if it's a positive number, that means as x goes to positive infinity, y goes to negative infinity, also positive infinity. As x goes to negative infinity, which is go to the left, y goes down. Negative infinity. Well, if, for example, y equals to negative ax to the 5th power, then we know that this, since it's a 5, right, it's going to be similar to a cubic function. And with a negative, this is going to be reflected over the x-axis. So that means the graph, the end behavior, when we're talking about end behavior, we're talking about these two parts. It's going to be similar to the flip cubic function. So that means as x goes to the left, y goes up. As x goes to the right, y goes up. That's it. All right. So the next part is since we learned power function, what is polynomial? So polynomial was basically it's a multiple power function combined. By definition, it looks like this one. Okay, this might look complicated. If I give you an example, you will know what is a polynomial function look like, such as 3x to the 4th minus 7x squared plus as to the 9th plus a plus 2/3 of x to the 5. This is a power function. Power function was a multiple power, this is a polynomial. Polynomial is a multiple power function combined. So we have a 1 power function, 2, 3, 4, 5. Totally 5 power function combined. Usually we will rearrange that with the highest power on the top and the lowest power in the bottom. Now let's talk more about the power function. For example, if we use this power function, n means the degree of the polynomial, means polynomial function, and then that is the highest exponent, of the variable. Now let's take a scan on the example that we have. What is the highest function, highest power? Well, the highest one is in here, 9, right? So that means the degree of this function is equals to 9. Degree of this function fx, let's say this is equals to fx, is equals to 9. DEG means the degree. And then which one is the leading term? Well, the one that with the highest exponent is going to be the leading term. So that means the leading term will be this guy, 8x to the 9th power. We don't look at the coefficient, we look at the highest exponent. And then 8 is the leading coefficient. Okay, then with this, we can talk about the end behavior, because here's the mark. The end behavior of a polynomial, it will be determined by the leading term. So for example, the leading term in this example is as to the cube. So that means the end behavior, first of all, this is a odd number. So that means we expected this is going to be similar to y equals to x cubed, and also we need to check the coefficient since it's a positive number, so that means it's similar to x cubed. So that means the end, it will look like this. We don't care about what happened in the middle right now. Now it's just the ending part, which is where did they go as x goes to infinity. So that's how we found the end behavior of a polynomial. Now, here is an example. Oh, let's check our ends on decimal. So, what we have on our example is 3s to the 4 minus 7x squared plus 8x to the 9th, and then plus 7 plus 3/3 x to the 5th. Look, if you look at this graph, it doesn't matter what happened in the middle. If you see my mouse's the cursor here, this is the middle part. We don't care. What we care about is the end part, which means as x goes to the left or goes to the right, where did the function goes? If x goes to the left, the function goes down. If x goes to the right, the function goes up. So that is similar to y equals to cubic function. They all goes to the same direction as s goes to infinity. Okay, now here some example about I want you to find the degree of the polynomial and the leading term and the leading coefficient, also the end behavior. EB means the end behavior. So first one, fx equals to 3 plus 2x squared minus 4x cubed. So where is the degree? So the degree is the highest exponent, the highest power, which means in this case, the degree equals to 3. Now, where's the leading term? So the leading term is the term that with the power function with the highest exponent, which is, don't forget the negative sign, which means it's negative 4x cubed. So the leading term is negative 4x cubed. So where is the leading coefficient? Then we need to look at the leading term. So, leading coefficient, which is, look at the leading term, is negative 4x cubed. So here is the leading coefficient, which is negative 4. So what does the end behavior look like? So the end behavior, it will be similar to what? Well, similar to a cubic function. Also, since the leading coefficient is a negative, so that means it's going to be similar to the negative leading coefficient, like this. As x goes to the left, y goes up. If x goes to the right, y goes down. So that's the end behavior of this example. Let's try a different one, such as f h of x 5t squared minus 2t cubed at 17. Well, this one, the degree, where is the highest exponent? Would be 3. Still 3? Let me change the number. Let's say 4, if this is a 4. Well, the degree is equal to 4. The polynomial, the degree of the polynomial is 4. And then the leading term is the one that with the highest degree. Negative 2x to the 4th, and then the leading coefficient is negative 2. So the end behavior, it will be similar to what? Well, since this is an odd number, so this means it's going to be similar to x squared. And the leading coefficient is negative, so that means it's going to be similar to negative x squared. It will be a upside down parabola. And here, this two part is the end behavior. As x goes to the left, y goes down. As x goes to the right, y goes down. You look at where did the arrow goes. Okay, let's work on another one, such as number 3. Let's do g. G of a equals to 3 times a squared, and then a minus 1 times a plus 4. So what's the degree? Oh, it looks like this guy, right? Square, but that's not true because this is a multiplication. When we're talking about a polynomial, their combination should be add or subtract. It's the sum instead of multiplication. So that means we need to distribute the function. We can also make a guess. So let's take a look how many a's in here. Here we got 2a, and here we have a 1. Here we got 1. When you multiply them together, you will end up to get 4a. Well, let's check our answer. So the first thing is, let's distribute 3a into the first one. We have a 3a cubed. Look, 2a multiple 1a. You're expecting to get 3a's. So that means we get a to the 3rd power. And then minus 3a squared. And then times a plus 4. And then we use FOIL. We have 3a to the 4th at 12a to the cubic minus 3a cubed, and then the last one is minus 12a squared. Look, as what we predicted. So the degree would be the highest power equals to 4. And then the leading term is 3a to the 4th. In this case, we don't even need to look at the leading coefficient because this already gives you enough information. The m behavior is going to be similar to what? A positive x squared, because this is an even number. If it's even, similar to x squared, so that means the m behavior, it will look like this way, which is when x goes to the right, y goes up. When x goes to the left, y also goes up. Okay, that's it for this chapter, to this section. I'll see you in the next video.